I mean, yeah, Redis is irresistible. Yep, so we already did the stages and RDB persistence, and we just checking how the replication works and how exactly the handshake works, and what exact messages they, like the follower sent to leader and leader sends to follower in order to do a handshake. So yeah, like there are 3 parts for the handshake, and this is the first one. And they say that when replica just starts up and it is configured to follow some master, then this replica sends a ping message to the master. Let's try to verify that. Okay, we already missed this ping initial because we started Tcpdump after we started our Redis follower. So let's exit our, so at the top I have a Redis follower and at the bottom I have a Redis master. So let's stop Redis follower. Docker stop Redis follower 1. And I'm not sure if I just started, if it will send the ping again, but let's try. So Tcpdump, nothing much going on because there is no follower, there's no like replication or messaging going around. And let's start our Redis follower 1. And we see, yeah, we saw a lot of messages. Let's go back. It says 18 packets captured. 1, 2, 3, 4, 5, 6, 7, 8. Where did it start? Where did it start? I think this one. I think it started here. So let's search for the ping message. Reply length follower 1. There is Queen what? Oh, here it is. Here it is. Ping. Yay, we see. So this is like so there is a ping and there is also PONG. Let's try to understand like the sneeze Ukraine. Yes. Let's try to understand. How do I distinguish what incoming traffic from outgoing traffic? Does anyone know? I think, yeah, okay, so this is like the first one says Redis follower 1, and then there is an arrow to something 236A, and I think that's us, like the master. And that's the message ping. And then there is also something else. I'm not sure what this second message is about, but the third one is from IP236A, and I think that this is a master. And 2, like there is an arrow to Redis follower 1. This is a PONG. Okay, great. So this first one, at least it does work. Let's see what the next challenge is. And this is about the replica sends REPLCONF twice to the master. Let's try to find it actually. We don't need to run anything else. Okay, so I see this one. This should be the first REPLCONF. And there is a resp OK. I think like the follower sends REPLCONF and the master says OK. Then the follower once again says REPLCONF. And the master says OK. Good. And then there is a okay, this is the second stage of a handshake. And then there is a third one, which is the replica sends PSYNC to master. And I think we already have this one. We already have, like after 2 REPLCONF, there is a PSYNC. And the master says to follower, continue with some big number. Maybe we will get to that. Let's move on. in these stages and see what happens, what is expected to happen. Receive handshake. This is like these two challenges were like these three challenges were about what the follower should do to establish a handshake. But now this two is actually about that master should accept this handshake. And yeah, like the master receives a ping from replica. And like we already checked that before, that master, like Redis instance, any Redis instance answers PONG to ping. And we saw this one. We saw this PONG message. So we already verified that. And then in this stage, the master receives REPLCONF twice from the replica. And it is expecting OK as a reply. And we did see that. We saw like first REPLCONF, OK, we saw the second REPLCONF, we saw OK. Yeah, so this challenge is about verifying that the master says OK. What else do we have? There is a receive handshake. And this is the last one. When master receives a PSYNC, what master should say. Okay, after the replica sends REPLCONF twice, it will send PSYNC $-1 command to the master. The first argument is a question mark. This is the replication ID of a master. It is question mark because it is the first time the replica is connecting to the master. Okay, I think this is like what they mean. So the first argument is a question mark. And the second argument is -1. What does it mean? The question mark, this is the replication ID of the master. It is question mark because this is the first time the replica is connecting to the master. So that kind of implies that the second time we connect to the master, instead of question mark, we will give some information. And I think that can be something like the last replication ID that we saw from the master. The second argument is -1. This is the replication offset. It is -1 because this is the first time the replica is connecting to the master. So I think I have a lot of, like, not a lot, but like mostly I have Kafka background, and there is like a concept of replication, often like an offset and last kind of stable offset in Kafka. I think that should be similar. And actually I saw some spoilers kind of for this, and the replication offset, like offset increases every time you like Redis master or follower, they process some command, and it's kind of like if you know the replication offset of an instance, you kind of know what was the last command this thing have completed. This is the first time the replica is connecting to the master, and the second argument is -1. So like the first argument is a replication ID and replication offset, and these are two different things, replication ID and replication offset. Fine. The final command you receive will look something like this. This is a lot. We did that. We learned how to read this thing in the first stream, and I think this is like *3. I think that means that this is an array of a size 3, and then like this $5 means that the length of the next thing will be 5, and PSYNC actually is 5 letters, and the next one is $1, which is the size of a question mark, and the second one is $2. This is a length of -1. Okay. The master needs, oh sorry, I think that's my MacBook doing this. The master needs to respond with plus FULLRESYNC REPL ID 0 \r\n FULLRESYNC 0 encoded as a RESP simple string. Here's what the response means. FULLRESYNC means that the master cannot perform incremental replication with the replica and will thus start a full resynchronization. REPL ID is the replication ID of the master. You've already set this in the replication ID and offset stage, and at that time we hard-coded some value, and like 0 is the replication offset of the master. You've already said that. We did hard-code some values. It shouldn't be hard-coded, but I think later on they will explain to us what it should be actually. Okay, let's try to find the... okay, so we have a PSYNC. From follower to the master, we have a message saying PSYNC, but I don't see any... That's interesting. I don't see any question mark or -1. What else do we have? From follower to master, continue something something. Not sure what that means. And then from follower to master, not sure what that is. And then from follower to master, REPLCONF Acks 690. Interesting, not exactly what we expected. Because we reconnected from follower second time. That's a good guess. So you say if, because I stopped the follower and I started it. If I delete this container altogether and then like do docker run from the start, looks like we need to re-init master. Or do you, maybe just deleting the docker and like recreating the follower again will not work, because this is the same port and our master kind of remembers that this is, I saw a follower from this port. Let's try. Docker bits. So first I will try just to, I'm not about re-initting master. Let's not do it. If deleting the Docker container and starting it all over again will not work, let's just try to start a follower on a different port so the master will know that this is actually a new follower. So what do? Docker stop follower, Docker rm follower, Redis follow1, new follower, it's okay. Okay, so we have our master. I don't kill our master. A Tcpdump. Let's do Tcpdump. Okay. Let's do a lot of this, so it will be easier to find. And what we do? Docker run Redis follower1. Okay, let's stop. Okay, what do we see? So there is a PSYNC, there is a PONG, there is the first REPLCONF, okay. There is a second REPLCONF, okay. Oh, it did work. Just deleting the container altogether and recreating it did work. We see PSYNC (?) -1. From master to follower, I'm not sure what that is. Doesn't look like it has this like REPL message. From master to follower, what is that? Also not sure. What? We didn't see FULLRESYNC. Let's try another time. Maybe I stopped Tcpdump too early. Docker stop Redis follower1, Docker rm follower1, Tcpdump. Can I just grab something from Tcpdump? Can I just grab this resp thing? Docker run. Okay, let's go. What? TCP. Okay. Well. Well, we see PSYNC (?1), but we don't see. Oh, here it is. Here it is. FULLRESYNC. Perfect. Perfect. Nice. 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 Okay. Okay, so we saw PSYNC (?1), and the master needs to respond with FULLRESYNC with something quite big and something else. REPL ID. Okay, this long string is a replication ID, and there is a, okay, in instruction it is 0, and 0 means this is the replication offset of the master. And I think we have a not 0 but something. That's because we already actually run some commands against master, and we saved some data to the master. So replication offset is not 0. Okay, because we have some history of commands we processed. Fine, fine, perfect. I'm really curious about replication ID and how exactly it is created and what exactly does it mean, but we can work it out later. Empty RDB transfer. In this stage, you'll add support for sending an empty RDB file to the replica. This is part of the full resynchronization process. Full resynchronization. When a replica connects to a master for the first time, it sends a PSYNC (?1). We saw that. This is the replica's way of telling the master that it doesn't have any data yet and needs to be fully resynchronized. Okay. The master acknowledges this by sending a full resync response to data, to the replica. Yeah, this one. After sending the full resync response, the master will send a RDB file of its current state to the replica. Okay, we see that after full resync, we already see some messages, Redis 0012M something something. I think that is supposed to be the RDB file. We talked about the RDB file on the first stream, and yeah, it did kind of look something like that, and we only have one key and value set. So maybe like this string is our whole RDB file. Because after that there is REPLCONF, and nothing that looks like an RDB file. Okay. After sending the full resync response, the master will then send an RDB file of its current state to the replica. The replica is expected to load. We can check that. We can actually check that. We know a command to save, to create an RDB file. RDB file is kind of a snapshot of the current state. And the command was Redis CLI save. Okay. And it's like this db.rdb is exactly my snapshot, and I can do something like cat dump. Okay, we see, what is that? Okay, we see this Redis 0012. I think this is the version. This one is a version, yeah. So it has some more. It like I can see Lenka Kolenka, but here in Tcpdump, I don't see anything that looks like Lenka Kolenka. You know? Maybe I just shouldn't kill my Tcpdump and let it watch the traffic longer. Okay, let's try to hear what's going on. The master will then send RDB file of its current state to the replica. The replica is expected to load the file into memory, replacing its current state. This is an interesting one, because if I log into the follower, I don't expect to see this dump RDB file in a data directory. I think it does load just to the memory. We can try to take a snapshot on the follower and read, and I guess there will not be Lenka Kalenk. We can just try to get this key from the follower. Docker exec. Let's go to the follower and say Redis CLI. What do I want to say? I want to say get Lenka. Sorry, I always forget that this is not the default port. Yes, if I say Redis CLI save on the follower. Sorry. Okay, and here there is my snapshot. And if I look what's in there, this is the same thing, the same snapshot that the master has. Okay, but I think I didn't see it in the Tcpdump because I stopped Tcpdump too early. For the purpose of this challenge, you don't have to actually construct an RDB file. We'll assume that the master's database is always empty. Just hardcode an empty RDB file to send to the replica. You can find a hex representation of an empty RDB file here. The tester will accept any valid RDB file that is empty. You don't need to send the exact file above. The length of file /r/n contents of file. Okay. Let's go to the next challenge and we'll see how non-empty snapshot is replicated. Oh, this is an interesting one. This says Single-Replica Propagation. That kind of suggests there is an existence of Multi-Replica Propagation. In this stage, you'll add support for propagating write commands from a master to single replica. Okay. Command propagation. After the replication handshake is complete and the master has sent the RDB file to the replica, this is our case, the master starts propagating commands to the replica. Makes sense. When the master receives a write command from a client, it propagates the command to the replica. The replica processes the command and updates its state. More on how this propagation works in the replication connection section below. Commands like ping, echo, etc. are not considered write programs, so they ain't propagated. Makes sense. Commands like set, delete, etc. are considered write programs, so they are propagated. Makes sense. Replication connection. Command propagation happens over the replication connection. This is the same connection that was used for the handshake. Propagated commands are sent as RESP arrays. Yeah, we saw a lot of RESP messages. I actually used grep to filter only RESP messages just because I don't understand any other messages anyway. For example, if the master receives set full bar as a command from a client, it will send this array to all connected replicas over their respective replication connections. Makes sense. Replicas process commands received over the replication connection just like they would process commands received from a client, but with one difference. Replicas don't send responses back to the master. They just process the command silently and update their state. Similarly, the master doesn't wait for a response, okay, but master can explicitly ask for the acknowledge. Okay, what's going on? It'll then connect to a TCP server as a replica and execute the following commands. PSYNC question mark -1. The tester will then wait for a server to send an RDB file. Once the RDB file is received, the tester will send a series of write commands to the program. It's a separate Redis client, not the replica. Tester will send write commands to program. You mean to master? As a separate Redis client, not replica. And it will then assert that these commands were propagated to the replica in order. Okay. So tester acting as a client writes to master. Makes sense. So what do I want to do? I want to watch traffic actually, like we did watch traffic on master. Let's watch traffic on follower. Okay, and I do tcpdump. Okay, let me okay, let's watch all the traffic. And then, yeah, it did some, yeah, it's like it continuously asking for Acks, and it continuously acknowledges something. Yeah, good for them. They're in sync. And on master, I want to write Redis CLI set full bar. And let's see if, okay, I did see it. Not ideal, but REPLCONF. Okay, this one. We saw a message on from leader to us, like follower. Length 54 resp select 0 set full bar. Not sure what select 0 means, but the leader got this comment, set full bar. I think we can try to read this Redis CLI -p6380 get full. Yes. The data is replicated. Perfect. Notes: a true implementation would buffer the commands so that they can be sent to the replica after it loads the RDB file. For the purpose of this challenge, you can assume that the replica is ready to receive commands immediately after receiving the RDB file. Yeah, like in a real system, there are a lot of details. So that was a single replica propagation. What's going on there? There is a multi-replica propagation. In this stage, you'll extend your implementation to support propagating commands to multiple replicas. So this is the same thing. We start multiple replicas, they do a handshake, then we set some value on the master, and then assert that each replica received those commands in order. Okay. The in order part is actually interesting because like there are delays in real network. I think like in real network can reorder these messages. I think that would be quite a lot of efforts to simulate reordering of messages in a network via my two Redis containers, Docker containers. But this is some advanced topic. We're not going to do it right now. What I want to do is create a third tab just so we don't get confused. So the so the top one is a follower one. In the middle one, we will create another follower, and the bottom one is master. I have a master, I have one follower, I want to start another follower, and like Lenka full bar will be passed to the second follower in the RDB snapshot. And then I will watch traffic on both of the followers, and I will add another key to the master, and I will watch this traffic info on the followers. Makes sense? Sounds like a plan. Let's do this. Docker run. So I'm gonna run a follower 2. It's gonna be on port 81. And here gonna be port 81, and it's gonna be a replica of the same leader. Let's do this. Okay, let's exec to this container. Okay, and I want a tcpdump rep, yes, about. Okay. Okay, the first one is already started replicating something. I didn't even write something against the master. So let me do Redis till I said we did Kalenka, we have full bar. What else can we do? Do you have any ideas? What can I don't want to use test. Okay, I'm gonna do bar 2. Makes sense. So I did make bar 2. Oh, and now I need to find this. Okay. I see this on the, yeah, this is it. On the first follower, I see set bar 2. And I need to find the same message on the second follower. Oh, the second follower was just doing ping. Oh, and act and select set bar 2. Yeah, we found it. Perfect. So okay, we can do replication to 2 replicas. Perfect. Command processing. What does it mean? So what's going on here? We did multi-replica replication. This is called command processing. What do you mean command? We already did like set command. In this stage, you'll implement the processing of commands propagated to the replica from the master. Command processing. After the replica receives a command from the master, okay, it processes it and applies it to its own state. Makes sense? This will work exactly like a regular command sent by a client, except that the replica doesn't send a response back to the master. Makes sense? We saw that. For example, if the command set foo1 is propagated to the replica by the master, the replica must update its database to set the value of foo to 1. Unlike commands from a regular client, though, it must not reply with OK. Yeah, we saw that. We saw exactly this. We see this set bar command, and we don't see any OK reply. That's so. I mean, they test only setting values to master and getting it from some replicas. We already did that. What does it say? It is not guaranteed. Oh, sorry. It is not guaranteed that propagated commands will be sent sorry, how do I move my face? Sources, yeah. It is not guaranteed that propagated commands will be sent one at a time. One TCP segment might contain bytes for multiple commands. Oh, just like in real life, no one guarantees that you will be given one task at a time. That's true. Okay, I think we already did test this thing. So I don't know what else. It's not that they've given us some new commands that we should support. Oh, acknowledgements. This is an interesting one. In this stage, you'll implement support for the REPLCONF get Ack command that a master sends to a replica. This is an interesting one because we saw a lot of Ack, kind of that the Ack that the follower sends to master, but I don't think we saw any get Ack command that master asks of replica. Unlike regular commands, unlike regular commands, when a master forwards commands to a replica via the replication connection, the replica doesn't respond to each command. Makes sense? It just silently processes the commands and updates its state. That is called asynchronous replication. Yeah. Yoo-hoo. Since the master doesn't receive a response for each command, it needs another way to keep track of whether a replica is in sync. Yeah, because master sends some command to replica doesn't reply, and master doesn't even know what's going on with the replica, if it's alive or not, if it did store this data or not. Ack is short for acknowledgement. Redis masters periodically ask replicas to send acknowledgements. Each Ack contains an offset. So yeah, this is a good one. So here, for example, we see Ack 4142. What does it mean? And we see that this 4142 doesn't change, but yeah, so this is a good one. Before the command to set bar2, it says Ack with the value 4090. And after they got a set command, they acknowledge back another number. They say 4142. I guess this is something like 52 bytes was, yeah, nice. So this is the length of the command set, like resp select 0 set bar2. The length of this command is 52, and 4090 plus 52 is exactly 4142. Nice. Hehe. This is a good one. This is like, we know what this offset means. It just like we increase the offset every time by the length of the command we process. Nice. Yeah, that's true. Which is the number of bytes of commands processed by the replica. Perfect. We'll learn about how this offset is calculated and used in later stages. In this stage, we'll focus on implementing the mechanism through which a master asks for an Ack from a replica. Get Ack command. This is an interesting one because we saw a lot of messages from replicas to the master saying, yeah, Ack, but we never saw get Ack command from a master. So what I want to do is, let me Tcpdump, like watch my traffic on master, but actually let me grab just for this command. And let's see if the master will ever ask for the acknowledgement. Maybe the master asks for the acknowledgement only if it didn't see. I think like follower can send Ack like unprompted without master asking. And if master saw acknowledgement like recently, maybe they will not even ask. The question is, should I stop my followers? If I stop my followers and my followers are silent for long enough time, will the master ask for the acknowledgement? That is the question. Let's try to do this. So I will docker stop follower 1, docker stop follower 2, and let's wait for the master to ask. To expand collapse, when a master requires requires an ACK from a replica. It sends REPLCONF get ACK star command to the replica. This is sent over the replication connection. Okay. When the replica receives this command, it responds with the REPLCONF ACK offset response. We saw a lot of these ones. The offset is the number of bytes of commands processed by the replica. Yes, we saw this one. It starts with 0 and is incremented for every command processed by the replica. In this stage, you'll implement support for receiving REPLCONF get ACK. Okay, you can hardcore the offset for now. Okay, maybe like I still don't see master asking for the acknowledgement. Will execute your program like this. What do I do? How do I make master ask for the acknowledgement? Timing of sending get ACK. I'm confused about the timing of sending REPLCONF get ACK from the master. For the master, should it be sent after the master sends set, or be sent after the master receives the wait command? We didn't even talked about the wait command. There is a next challenge about the wait command. Okay, it says after wait. The logic here would be, are there enough clients that I'm aware of that have an up-to-date replication offset? If yes, return count right away and don't send get Acks. I think this is what happens. I think our master has enough replicas and their replication offset is up to date. So the master doesn't even need to ask for the acknowledgement. If no, append a get ACK to the replication stream. So all replicas will get it and wait for the Acks to pour in. Okay, I mean, it's doing fine without get ACK. So let's move on. Acks with commands. In this stage, you'll extend your REPLCONF get ACK implementation to respond with the number of bytes of commands processed by the replica. As we saw in the previous stages, when the replica receives a command from the master, it processes it and updates its state, yes, in addition to processing commands. The replica also keeps a running count of the number of bytes of commands it has processed. A replica keeps a running count of number of bytes of command it has processed. So this is the replication offset, I guess. Yes, this count is called the offset. Perfect. When the master sends REPLCONF get ACK command to a replica, the replica is expected to respond with REPLCONF ACK offset. The returned offset should only include the number of bytes of commands processed before receiving the... Okay, yes. I mean, we didn't saw master asking for get ACK, but we saw a lot of confirmations with the replication offset. That's true. Okay, this is an interesting one because I saw PSYNC not during Handshake at some random point, at point that seemed random. But now there is information about that. The master then sends a PSYNC command to the replica. Masters do this periodically to notify replicas that the master is still alive. This is a good one. Yeah, this is useful to notify people that you're still alive. The replica must silently process the PSYNC command and update its offset. It should not send response back to the master. Okay. So there is a PSYNC, and yeah, we saw PSYNCs. We didn't see PONG as a response, but this thing states that replication offset should be incremented. The master then sends REPLCONF get ACK again. This is the first time. The replica should respond with REPLCONF ACK 88, so that 88 is a current replication offset. Okay, what else can we do? I mean, if master isn't asking for the... I think this is just some kind of optimization that master doesn't ask for the acknowledgement. If it received acknowledgement quite recently. So that's fine. Let's move on. Wait with no replicas. Oh, okay. Okay, we're still working on instructions for this stage. You can find notes on how the tester works below. This is an interesting one, but like they say, we will not tell you what that is, but there is a command wait. It'll expect to receive 0 back immediately since no replicas are connected. Okay, I think num replicas timeout. Time complexity. Oh, this is nice. I mean, this is nice that, like they say, this is slow blocking and time complexity is linear. Linear of what? The time complexity is constant. Perfect. Okay. Yes. I'm looking at this exact page. This command blocks the current client until all the previous write commands are successfully transferred and acknowledged by at least the number of replicas you specify in the num_replicas argument. If the value you specify for the timeout argument in milliseconds is reached, the command returns even if the specified number of replicas were not yet reached. This is a very useful command. This is a very useful one. Okay, this is like, it kind of forces replicas to become in sync, at least at the point, like at the current point. Like we need, this is a good one because like you can specify how many replicas should be in sync with you in order to continue. Like for example, if I have a cluster of 3 Redises, master, follower, and I can say, okay, I can consider some message like written, and I'm sure that I will not lose this one if this is replicated to at least 2 instances, like master and at least one of the followers. And you can write some message, and then you can say wait 1 timeout, and you kind of wait for at least 1 replica to replicate this one. This is a good one. I like this comment. Oh, it says something about transactions. Transactions will be like in the next chapter, but I see how this comment can be useful in transactions. Nice. A timeout of 0 means to block forever. Since wait returns the number of replicas reached. Okay. Wait returns the number of replicas reached, both in case of failure and success. Okay. Nice. This is nice. This is a cool comment. What else do we have? Wait with no commands. What you mean? What do you mean? Okay, still working on instructions for this stage. But I think something like if I didn't set any values, if I didn't write anything to my master, but I want like 3 replicas to acknowledge like offset 0. The response to each of these comments should be encoded as resp. Oh, this is interesting. If wait is called with a number lesser than the number of connected replicas, the master should return the count of connected replicas. The number of replicas created in the stage will be random, so you can hardcore 7. Interesting one. What will, like I have 2 followers. So what will I say wait, for example, 4? What will it, I think it will time out and return like 2, the value, the number of followers actually reached. Okay, 60,000, maybe that's a lot. Let's do a timeout of like 100. Yes, it did return just 2 because we have like maximum 2 followers. Makes sense. Okay, the last one for today. Okay, still working on instructions for this stage. But yeah, I see what you mean. There are multiple replicas. Each will complete Handshake and expect to receive an empty RDB file, tested, then connect to a master as client, and send multiple write commands interleaved with wait. Yeah. Okay, so yeah, I mean, makes sense. We write some data, we want it to be stored on at least this amount of replicas, we write some other data. We wait until this data is propagated. Perfect. So yeah, like Tcpdump is not perfect without Wireshark, but it does the job. We did cover the whole replication chapter, it was quite big. The next one will be streams and then transactions, and that's it. Okay, thanks everyone. Bye bye.